Hey everyone, John here. So in today's video, I'm going to be revisiting the two-sum problem that I solved with ChatGPT a month and a half ago, and hopefully I can solve it without the help of AI. Okay, so two-sum, given an array of integers nums and given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So like for example, 2, 7, 11, and 15, the target is 9. So two of these specific numbers add up to 9, which is 2 and 7. And then I have to return the index 0 and the index 1, right? Okay, and then for this one, same thing, kind of, 3, 2, 4. I have to return 6, so I have to return this index and this index to add up to 6. And then this one, I mean, like there's really just two numbers, so I'm just adding the two numbers together. Yep. So what I'm thinking is, do you remember that? Like I'm going to use 2 pointers for this. So I'm going to do pointer 1 and then pointer 2. Sure. So my approach is like, because for this one, I think for this one, these two are pretty easy, I think, to do. But this one is a little bit harder because they're not sorted. So somehow I have to figure out how to okay, so what I'm gonna do is I'm gonna like for if the array is sorted, I'm gonna start at the left pointer and I'll make a pointer at the farthest left end and a pointer at the furthest right end. So if the amount is less than the target, I'm gonna add 1 to the left pointer. Do you know why I'm doing that? Yeah. Because like obviously the only way to go up is like move to the left. That's kind of what I'm thinking. Yeah. And then like if it's less, then I have to move 1 to the right. But the problem is like I can't do it on this.
Why not just sort it?
Because I have to return the index. And if I sort it and then it gets screwed. But like what I'm thinking is once I have the two indexes of the ones that sum up, I could just like have the initial array. I could have the initial array and then I could just search that array for where the numbers are at.
Yeah, that works.
Does that make sense?
Yeah.
And then
find the indexes of those specific elements.
Yeah, and then return those.
You know they're unique, right? I mean, there's unique elements in the array or no?
No, there's not. Okay. Is that bad? I don't know, but like, let's see. I'm gonna do a dry run as what's his name said. That one guy. Awesome guy. All right, okay, pointer 1. I'm gonna start at 0 because that's like the furthest left index, and then -1 because that's the furthest right index. And then I'm gonna start an if statement like I was saying. So if I think if pointer, do I do pointer 2 or pointer 1? I mean, if pointer 1 is less than, or do I have to do a while loop here? Maybe I do a while loop. While pointer 1.
What's the reason?
Because like, the reason is because like I'm gonna iterate these numbers. I'm gonna add the plus minus to them. Like you can't really do that with the if statement, I think. You know what I'm saying?
I would just say one thing with the pointer 2 is like I feel like it's bad practice to keep it at -1. That's like shorthand. Like why not just give it the real index?
Why not just give it the real index?
Yeah.
What does that mean?
Like give it the index of 4. Like here, 0, 1, 2, 3.
Oh, okay. So just be like length of nums -1.
Yeah, I think so.
What's the difference though?
I don't know. Like no one really does -1. That's like a shorthand for like accessing the last element. But here, it's easier to debug.
Oh, okay.
Like you know, like when it says like 3, you just count. Oh, it's the third one. Oh, it's second. Oh, that's the second one. Now you can do while pointer is less than pointer 2.
While pointers, okay.
So that's how you like can like write a while loop to make them move forward.
Okay, so then I don't have to have a counter.
Yeah, exactly.
I see.
So like you can make them converge.
Yeah, and the reason why I'm not doing, remember, like the reason why I'm not doing it this way, or like the equals, is because like sometimes the array could be, what do you call it? Like the array could be even numbered. Like the length of the array could be an even number. And if it's not this one, then they'll never convert. Like sometimes they can never converge. Do you know what I'm saying? 1 or 2. Well, pointer 1 is less than pointer 2. Wait. While pointer 1 is less than pointer 2. And then I'll have to put an if statement inside of here. If point nums, if nums pointer 1 plus nums pointer 2 is less than target.
Yeah.
Then I have to do pointer 1 plus equal to 1.
Why?
Because like I'm moving, because the sum of the two is like less than the target, so I have to like add 1. Like I'm only able to solve this though.
Yeah, but do you get the math behind that?
Yeah, you're just adding to the pointer here, and this one is still at the same one.
Yeah.
Right? And then let's do like a elif statement. Elif nums, like pretty much the same thing but the opposite. Greater than the target. Oh, whoa. What did I do?
You went to full screen.
Oh, okay, that's fine. Then pointer 2 minus equal. Okay, so moving forward, this is what I'm supposed to do, eh? I never thought about. I always just like kind of. It just seems more intuitive for me to do it that way.
Minus 1.
Kinda, because like you're moving from the left. I don't know. Okay, minus equal to 1. But yeah, now I see what your point is. Actually, I don't. Yeah, no, I get what you're saying. Else, return. What? Okay, now I'm confused. What am I doing here? Okay, so return. So if they are the same, return index of.
Well, the pointer ones are already the index, right? There's already.
Oh, okay, yeah. Return pointer 1. Pointer 2.
Yeah, in an array.
What? Oh, you want it?
That's how I want it.
How the heck do you do that? Like that? Is that right?
Yeah.
There's supposed to be a space here, I guess.
You good? You know that's gonna get one of them.
Yeah. Okay, let me try that.
Looks good. You probably get all the cases except for the second one.
Yeah, yeah. Okay. So now what I'm thinking is, okay, I'm gonna sort the list. List dot sort. And then I'm gonna store the normal list. Do you know what I mean? Because like once I modify the list, it gets screwed up.
Yeah.
But I'm gonna store the list so I can like kind of search.
Is there a way to augment the nums so that after you sort it, you still know the indexes that used to be there?
After you sort it, you can.
Is there a way to augment, like add data to each index?
Add data to each index? No, I don't know I don't know what that means.
Let's see. Let me try to think of it like, is there any way to like build a new array out of that same array, but that maybe each element is like a tuple or something?
Each element is like a tuple?
that contains the original number and the index that it used to be. I'll show you.
Oh, okay. Yeah, yeah.
You see that? You know
Yeah,
what I mean?
yeah, yeah. So like for
So
I,
this one would be 30 tuple, 2 1, and then 4 4.
oh, I
2.
see.
You see? Is there a way to do that?
Like with the hash map?
Or you can just build another array. Build another array and just like store that data in that array. Like here, let me just like say what I mean. Let's go to the bottom here. Like our issue right now is that we're given this array 3, 2, 4, right?
Yeah.
But the moment you're right, the moment we sort it, we lose the indexes, so we can't properly return this.
Yeah.
But what if I can build an array like this?
Oh, I see. Why can't you just make a dictionary like that?
Right? And now we take the array and we just sort it. We sort it by the first key.
Oh, okay.
And then now we just do the 2 pointers. And when we find the result, we don't return like the actual pointers, but instead we return these indexes.
I see.
Does that make sense?
Yeah, I see what you're saying here. How the heck do I even do that though? So, okay, so I'd be like, do I have to make a for loop to make that?
Yeah, you could even do it through a list comprehension.
Oh,
One
I see.
really nice hack is using this enumerate function that you should learn
Yeah.
about.
Okay, okay.
You see
Let
that?
me try to do this list comprehension first just for practice. So,
No, I see what
I do
list
nums.
comprehension is harder.
Really? How?
Or yeah, we'll see.
Okay. For I
Or,
In-
not really, yeah.
or for element. So we could be like a tuple, right?
Yeah.
So it would be like element. And then just
Just comma, comma.
Oh, it's just a comma?
Yeah. It's like building an array,
Element,
but
comma, and then element, then element. Oh, wait. So this should be okay, frick. Let me write this out. For element in list, right? That's a end piece.
or
And then
nums.
oh, my bad. For element in nums. So I have to return the, so this was, so the first digit is the element. And then how the hell do I return the index? of
Okay,
the
one syntax is this enumerate.
Nah,
So
let me,
just look
can you do it this way quick? Cause I just,
There's no way to do that because you're grabbing by element. You're grabbing. Well, what you can do is like you can go for I in range, and then now you have the index for I in range. Of the
Oh,
length.
I see.
When-
Yeah, yeah.
Because right there you have the elements, and it doesn't really tell you.
Yeah,
the index.
yeah.
But I know a syntax to get you the elements.
Okay.
but
Show me
I'll
that
show you
after. Yeah, yeah. Because like,
Yeah, you want to do it the way you know.
yeah,
it.
yeah, yeah. For I in range, length of, what was it? List
Nums.
or nums? For I in range, so then you do element.
What's element though? It's no
Oh.
longer defined.
That one's I. This one should be I, and then this should be nums I, right?
Yeah, you're already getting good. You guys getting good.
Frick, man. This is so confusing. And somehow this is a tuple.
Yeah, that builds a tuple. It's like a list. You could also build a list there. It doesn't matter.
Yeah, yeah.
But the tuple is just like
Yeah,
it's good because you can just apply sort on tuples,
yeah.
and it'll all like if you can build tuples with more than that many elements, but it'll always sort by the first one. And if two elements match, then they'll match on the second one.
Yeah,
But they like that's just a property of tuples.
yeah. Okay, so what is this gonna return?
I don't know. Print it out. Like you gotta learn how to debug it as well. Like before comment out a bunch of code and just print it out and just see what it's doing.
Print nums comp does it take so long for that?
See?
Ah, I see. Okay. So somehow, so to access the tuple, I can use the -1 function.
No, don't use the minus.
Don't use the -1. Do length of each -1.
No, just you know it's the one element no matter what. The tuples are always the size 2.
Oh, so I could just return 0 every time.
Like,
But I'm trying to return the index though.
yeah, if you want to access the index, you access the first index, like 1.
Yeah.
If you want to access the actual element, you access 0.
So let's see what it means if I do print nums comp 1. Oh shit, I submitted it. Oh god, I swore. Okay, what? Print nums 1.
It's there. You're printing out the tuple.
Oh, I'm
You
printing out
submitted
the
again.
tuple? Okay, my bad. Okay. And then but like, can't I do it like this too?
Yeah, that will get access
And then
to the element.
yeah, that will get me like what I'm trying to get.
Okay, what do you want to access?
But I
You wanna
want,
access the element.
but like, I was just gonna do this. Oh god, what? Am I canceled?
You're getting
swearing?
rate limited for running it like way too.
But I didn't submit it. But yeah, see what I'm trying to say? So now,
That makes sense, but I just don't like that syntax of using the -1. But like
but how else would you do it?
by just saying 1.
By saying 1? Oh, because they're all one tuple.
Yeah.
Yeah, I see.
one that
I
gets
see
the
what you
first
mean.
index.
I see what you mean. Yeah, okay. Because yeah, like I was automatically thinking that there could be a tuple with like multiple, right?
But it's just a preference thing. So
Yeah. No, I see
I
what you
feel
mean.
like it's just easier to debug when you're just working with the real indexes.
Yeah.
Instead of like deriving it. Because -1, -2, that's a derived index. It takes -2 and then it figures out the length and it minuses 2 from it and it gives you 3 or something if the length is 5. Instead of just knowing that it's 3. You know what I mean?
Okay. No, I don't get it. Let me use my bandwidth for this. Okay.
Okay, you have the pointers.
Okay,
Yes.
yeah, now I have the pointers.
Let's sort the nums comp now. Now we can sort it.
Yeah. So I could sort nums comp dot sort. That's it. Because this one doesn't make a new thingy,
Why did
right?
you throw 0 there?
Oh, I don't know.
And you messed up the name a little bit.
Where? Oh, numpy. Nums comp
too
dot
used
sort.
to-
Yeah, I'm too used to running that mp dot sort.
It's gonna break.
Okay, so why did it break this time around? Because I'm returning tuples instead of... What's it called? What I'm supposed to be. So, I need to return this instead. So it has to be like nums pointer 1
Nice.
with the 1 and then nums pointer 2 with the 1. Is that it? Oh, what?
You need to return an array.
I have to return an array?
Yeah.
Does this work?
Or like the way you did it before.
How
You
did I
just
do it
square
before?
bracket it.
Oh, yeah.
That's how you usually create an array. Construct an array.
Oh, God. There's no function to do that?
There's a function, but like this is like the most common way to just build the brackets. Shorthanded.
Oh, what?
Int is nums pointer.
Int is not
Oh,
subscriptable.
because you're accessing nums, not nums comp.
Nums comp?
Like you create. a new
Okay,
list,
yeah, I
you're
see.
accessing
Yeah,
your
yeah.
nums.
I'm accessing, yeah.
Does it make more sense though?
Yeah.
Approach?
Let me
Yeah, I'll let you cook. Okay.
let me
Finish it up.
I mean, I know what you're doing now. You're pretty much doing the same thing I was doing before, but like now you can easily access the thingamabob Why is the output not right though? Why isn't it returning like the wrong thing?
What are you comparing in 7? Line 7. Think about line 7.
What am I comparing in line 7? Oh. It should be pointer 1, 0. Oh, and this should be nums comp, eh?
Like why? What's the reason?
Because I'm actually because how do I say it? Like nums is no longer relevant because this entire code
like,
is based off of nums comp.
For line 9, like what's happening there? Like what are you comparing to the target?
I'm comparing the entire tuple. Right?
Yeah.
Yeah. Okay, nums comp, pointer comp 1, and then this should be 0. And then this should be nums comp pointer to 0. Nums comp pointer to 0. Nums. Man, what? Is this like a normal thing to do? I feel like this is kind of pointer 2. Is that gonna work? Holy crap. What the heck? Okay, yeah, let me review this before submission. Nah, I don't really care about my stats like that. It's already been down bad. My acceptance rate is already low. But yeah, no. Is that something I should care about?
No.
But yeah, like, okay, so should I just submit it or should I go over the code
Go
real
over
quick?
the code. Like we only made slight variations to your initial code. Like you almost had it. But the one thing you were right, like how was I gonna track the index when I stored it? And the answer to that is like augment the array.
Yeah, yeah.
And add to each element
The index.
So now when we do sort it, we have track of that. And then we just keep the same algorithm.
Yeah. And the reason why we made it a tuple is because we don't want the index to ever be touched by accident. Right? Because like a tuple,
right?
Yeah, tuple. Yeah.
Exactly.
Yeah, dude, I came a long way. I didn't know how to freaking say tuple at the beginning. You remember that?
Tupless. It's like one of those
tuple
words
is so embarrassing.
Whatever. Nah.
No, okay, yeah.
We might be saying it wrong.
Is that what they say?
I don't know
Is that what they say? Like I was reading it, I was like, what?
What GPT?
But yeah, like I'm pretty much doing the same thing, but instead I'm calling
What's your runtime?
What's my runtime?
Yeah, what's your runtime complexity?
How do I know? What's my runtime complexity?
Like how long does the algorithm take to run?
How long does it take to run? I don't even know. Like let me okay, let me do my version of what's it called? My version of sniffing tool. But yeah, okay, like what? Okay, so let's say this is the complexity, right? So isn't it light? Isn't it just ON?
Okay, nums comp, right? Usually I do it line by line and start thinking about nums comp. How does that scale? Line 4.
Line
scale
4?
Constantly, linearly.
Well, it's 2. It's 2.
Which?
These. Because like for every, that would be n complexity, wouldn't it be?
Wait,
like, cause
line 4?
Yeah, line 4. Because like, it would be 2n, right? Because like in the initial list, you have 1. But then if you just like sort the new list and store it, that would be 1n. But then really you're storing that initial element plus the index.
Yeah.
So it would be 2n.
Yeah. Usually you drop the constants though.
I drop the constants?
Because like usually...
What does that mean exactly?
Like when it comes to limits, like 2n, that scales just as much as n. Like you don't.
Oh, I see.
When it gets extra large, it doesn't even matter.
Yeah, it doesn't matter. Yeah.
About
I see.
So you usually don't think about it that hard. How I look at it is like 4, right?
Yeah.
Scale.
Because like the derivative of this is just n.
Exactly.
So you always have to derive the function.
Well, I guess like you just drop the terms. Like pretend I had a function that was 2n plus n squared, right?
Yeah.
dude, this n squared term will grow much faster than the n. Like, we don't even care about these smaller terms
Okay.
anymore. So
Interesting.
we just say it's an n squared algorithm.
All right. So you just take the
You take
yeah,
the
but
longest
like
term, the biggest
yeah,
term,
yeah.
and you drop the constants. Like, for example, if this was n to the
like the
power n,
largest exponent.
yeah, we're not gonna say, oh, my algorithm is 2n plus n squared plus n to the n. That's just like, we just don't do that. We'll just say we just have a factorial algorithm at that point. That's the biggest term, and that grows way faster than all the other terms. That we can kind of ignore the other terms.
I see.
Yeah, because like if this thing was really large, right? This thing, if it was moving like that, that barely contributes to it, to like that algorithm.
Yeah, yeah.
So we don't care about it.
Yeah,
we really
yeah.
only care about the largest term. I'm
Yeah.
pretty sure that happens in math too.
But isn't n like this, and then 2n is like this? So wouldn't you care at that point?
no, yeah, well, like 2n is probably like this, right? Or like it's just 2n is just like that.
What? Wouldn't it be like double the growth? Anyways, yeah. Because
yeah, maybe,
like at 100, this would be at 100.
But yeah,
this
no,
one
no,
would be at
that's n plus
200.
2,
Yeah.
It would be a little faster,
Okay.
but like it still doesn't matter. We always drop constants. That's just like
Okay.
the rule of big
Okay.
O
So
complexity.
so basically go to the largest, like the biggest factor in the function, and then use that.
Yeah, use that and drop the constants.
Okay.
So this one, and let's talk about time complexity. Don't worry about space complexity too much. Like in interviews, they really
Yeah.
focus
So
on
what is
time.
this exactly? This is n complexity
Yeah, why is it n complexity though?
because of what I just said.
Yeah.
Because I mean like in terms of memory.
Or let's talk about time complexity. How long does it take to build this nums comp? Does it scale linearly? Does it scale exponentially? Does it scale constantly?
It scales constantly.
So as this input gets larger, it's gonna take the same amount of time.
No, it'll take more time.
Like how much more time? Just linearly amount of time?
Yeah, linear.
Yeah.
Linear.
Okay, yeah, you're right. This is O of n. Like because we're creating a copy, we pretty much this takes just as much time to make depending on how big nums is. Pretend there's 10 elements, then it's gonna take us 10 seconds. If there's 20 elements, it's gonna take us 20 seconds. If there's 100 elements, it's gonna take us 100 seconds.
Yeah.
So it scales kind of linearly.
Yeah. No, I see what you're
Okay,
saying.
so that's O of n. This sort.
So it's O of n time complexity and O of n memory complexity.
Yeah, space complexity is using up O
What
of n.
space? Okay, space.
in your device.
O of n space and O of n time. Oh,
Yeah.
I see what this is saying now. Okay.
So basically, it's taking up O of n space because as this input grows, the amount of memory you're gonna use up also grows.
Yeah, that's right.
With it linearly.
Yeah, and then I mean, like obviously, if you add more to the
Okay.
list,
Sort is like the fastest sorts are n log n. That's just like you never
fastest sort are
never
n log
like
n.
dabbled into sorts yet. But how sorts work under the hood, you can't do it any faster than n log n.
okay,
And usually like n squared or something, or just some other ones. Like I'll show you sorts in a different day. But let's just say the fastest way to sort is n log n.
okay.
So we have this. Right? Okay, now we're at this final loop. How long does that take to run?
We're at this final loop. How? What do you mean?
Like how long does this line like this take to run? What's the runtime complexity? Like how does it scale? How does this scale based on the input? Right?
Yeah, it like isn't it? Because like it reduce like how do I say it? So okay, so let me just make a new one. Okay, so at the initial point, wouldn't it be like you're doing bigger calculations, aren't you not?
Okay.
Because like
Well, like I'm thinking about runtime. Like I want
because you're meeting in the middle.
Yeah. So I want you to tell me like how long it's gonna take this while loop to run. Like pretend I have a list of size 5,
Okay.
and it takes 5 seconds per iteration of this. How long would this take me to run?
5 seconds per iteration. 25. No, 20. 10. No, 20.
Would it just be 5?
What?
Because at each point you're moving them closer.
Okay, so one.
Well, if they're moving closer, like you're only moving one index at a time. At some point they'll meet up.
Yeah, yeah.
So if the element is 5, right? You start at one pointer. In the first iteration,
Yeah.
move this one. Second iteration, move this one.
Yeah.
It's like slightly under 5. Like it's like n minus 2, because you want to make them meet, right?
Yeah.
So pretend now I have a nums comp is 100. How much longer will this loop take to run?
Just under 100.
What if I put it to like 1,000?
Just under 1,000.
So how does it scale? Like in time complexity. What's the time complexity then?
Because wouldn't it be linear?
Yeah, it's linear because
Yeah.
as the
Because you're basically just slightly under it, like this kind of.
Yeah. But how you could think about it is like as the input size grows, this algorithm will just take that much longer. If it grows by 10 elements, then I just have to process 10 extra elements. It makes sense though?
Yeah, yeah, it's making sense.
Yeah. We'll just keep hammering it home
Yeah.
with the time complexities.
Yeah.
Okay.
I might be able to retain like the space complexity,
Yeah.
but not
Time.
the time complexity is kind of.
Dude, we'll do
Funny.
it for like we'll just keep going over. But here,
Yeah.
let me show you the different approaches to this question.
Yeah, like this is gonna submit.
Yeah, that's gonna submit, but there's actually a more optimal solution.
Yeah, you're telling me about the enumerate.
No, like
Whoa, I beat 5% of people. That's terrible, right?
dude, told you don't over index on that.
Don't over index on that.
Because your algorithm is n log n, because that's the biggest term.
That's the biggest term.
So your algorithm takes O of n, then plus n log n plus O of n. So the biggest term is n log n.
Yeah.
So that's your algorithm.
Okay.
I can do this algorithm in just O of n.
And log n is kind of like this, eh?
Well, it's like n
So-
times log n. I don't know. We'll have to graph it.
Okay.
Okay, let me show you. Let me
Okay,
show
okay,
your
okay.
channel the different approaches to this question.
All right. Okay, yeah.
Okay, switch.
Okay, can't believe it.
You solved it, bro.
Nah.
Good job, bro.
Holy.
Okay, let me just up this. Okay.
Yeah, show me that enumerate. I never heard of that enumerate.
Okay, enumerate is just a way that I can loop through elements.
But yeah, holy. So October 20 is when I did it the first time.
It's been 2 months almost. Month and
Damn,
a
I
half.
couldn't solve it still.
No, you solved it. You got way further. So enumerate gives you two things. It returns you a tuple, right? Where the first element is the index, and you could destructure it like that, and you just go like this.
How does it know the index though?
It basically does exactly what you said there. What it does is, see, it worked. What it does, let's just look at the syntax. Because we got to show your channel that you can look up documentation to enumerate.
Why didn't it just run it through ChatGPT, bro?
See, when you do enumerate, it creates a tuple. That's a bad example. Like eat, sleep, repeat. When you do enumerate, it turns it into this.
That one doesn't even make sense.
Basically, it kind of did what we did, where it turns all of the elements into a tuple. It's just like a function. It's just an extra function.
What's the bottom piece though? 2G, 3E. Oh, okay, that's for geek. I see. But like, doesn't this kind of? So now I have to call the second one. Like it would be one.
Where?
Like I'd have to flip
No,
this.
I flipped it here already. I just used it in the list comprehension,
Oh, I see.
and I just flipped it. I said for index and element, and then I flipped it when I build a nums comp.
I see.
Okay,
So this is like it always returns the index first and then the element,
yeah.
and then you could just rearrange it easily. I see.
So like we'll quickly go through the various versions. The worst version is n squared algorithm. And I don't know if you like mentioned it first, but the most like suboptimal way to do this question is by comparing every element to all the other ones. So I'll take one element and pretend what's my target?
What's my target?
My target's 9. Right? So the most suboptimal algorithm is just compare every single element until you see the result. So I'll compare 2 and 7, then 2 and 11, then 2 and 15.
Yeah.
Then I'll compare 7 and 11, 7 and 15. Then I'll compare 11 and 15. Like you compare every single option.
Yeah. Is that what I did?
No, you didn't do that. But that's the worst way to do it. And when you find the element that it equals,
yeah,
since you'll eventually find it because you're going to be comparing every single element to each other.
Sure. Then
you'll return that result. But that's an O of n squared algorithm. It's actually like almost half because you're comparing each one. You move there. See. So pretend the target was like 26.
Oh, okay.
Pretend the element was 26, right? We'll do 2, 7, that's 9, that's not equal it. We'll do 2, 11, that's 13, that's not equal it.
Yeah.
Right? These are not equal it. So now we already compared 2 with all the other elements. We know 2 is not in the result. We move this over. Now we're comparing 7 with all the other ones. We already compared 2 and 7 earlier, so we don't need to look at that. We just need to keep it at the next one.
Yeah, but when I sort it, like, I'm kind of just moving though.
Even when you sort it, you do the same thing.
Even when I sort it, it's not possible for me to like compare the same numbers though.
Or don't sort it. You don't need to sort it in this brute force way. Pretend here.
But like what I'm saying is like my algorithm is already more efficient.
It is. I'm showing the worst way possible to do it first.
It's like not possible to actually.
I'm literally showing you like the most brute force way first, and then yours is like the second.
I don't get this way though.
But it's like it's the most brute force because you're just comparing all the other ones with each other. Okay, look this one.
How would you even code this?
Okay, I'll show you.
Because like when I was like the way that I'm thinking about it is like, how is it even codable? No, make it a. No, it's alright. It's alright. I'll figure it out again.
For I in range,
I'll run it back.
You can look at your submissions.
Oh,
see all your code.
Interesting. Let's see what I put in October 20.
GPT.
Nah, no way I can write that.
Commented out and everything. GPT complimented it. No, I'll show you.
I cannot write that. That's crazy. What? Oh man. Yeah, let's see. Like, what was the difference between my method and that one?
I'm gonna get to it. I'll build up to it in a second. So I'll just show you this one. So we start for I in range length of nums.
All right.
And we basically started for j in range I plus 1 to length nums. So we're starting.
Okay, like when you write that, how do you? Because every time I write a function like that, I get errors about like how the index goes out of
bounds.
Range. So like to avoid that, remember yesterday, you were looking at one of my codes, and then at the start I had like if the length of this is wrong. Okay.
Yeah.
We can go over like another like. I'll show you which one I'm talking about.
So this is
like go to the other one that I was working on.
Look at this. That's the brute force algo right there.
What? I don't get it. How this works. I'm not good at like these nested for loops.
So what it's doing is it's starting. So we have 2 loops, right? So it's good to know both the solutions so that you could actually, because sometimes you need to brute force it. We start one loop here. Say this is I. We'll say this is I.
Yeah.
Right.
Yeah.
And then we'll say j is equal to here.
Yeah.
And what we're going to do is we're going to say for I in range length. So we're going to loop I all the way through here, right?
Okay.
But for each I, we're going to start j at I plus 1.
Yeah.
So let's just do a bigger example. We're going to start j at j plus 1. And now we're going to run this loop all the way till the end before we increment I to the next one.
Yeah. But this one, you can actually just like how how do you? So let's say, okay, for in this case, right? Like once this I pointer is at 7, how is it not at? How does this J pointer not start at 7 plus 1?
Or how does it?
Yeah, how does it do the first
Okay,
initial
first,
one?
first, okay. In this context, this is what it's essentially doing. For 3, it's basically saying I is equal to 0, right? Now I is equal to 0. When it evaluates this, it goes 0 plus 1, right? Now it's in this loop, and it's gonna keep doing this loop, but incrementing j. It's gonna go. It's gonna when it calculates this, it's gonna turn this to 1. It's gonna move from 1 to the length of nums. So it's gonna pretty
But
much.
what if I is 2?
Huh?
But what if I is 2?
Then it's 2 from here. Okay, I'll run it quick. Okay, pretend. Oh shoot. Pretend for I in range length of nums, and for j in range I plus 1 of length of nums, right?
Yeah.
So basically, this is the outer loop, and we start here. Now we go into the inner loop, and this j is gonna start at I plus 1. I is at here, and then we're gonna add 1. So it's gonna start there, and we said that we're gonna run it till the end of the length of the numbers.
What the heck?
It's the
I'm
raise,
so
right?
confused. Okay. But what I'm trying, like what I can't wrap my head around. So
Okay.
like if you go into
I know what you mean, but when I run it through the example, you're gonna understand
Alright.
it. So on the first, we're gonna run this loop. It's gonna go from j. It's gonna run from I plus 1 till the end,
Okay.
right? So that means it's gonna loop, and
Yeah.
at each point, we have these indexes I and j, and we're comparing if it equals the target.
That's
Because if it
right.
ever does, we're good.
I get that part.
Now that this j ended, we're out of here, right?
Yeah.
Now we pretty much go back into I. It ditches this. Like this thing, like it like goes into the loop again, and it ditches like the context from before. Like when you
I
go
see.
into, so it ditches that context, and now I is equal to 1 because it's moving into the next element.
Okay.
So we move that here.
Yeah.
Now this for loop instantiates again, right?
So where does it start for J?
It starts at I, and then we add 1. I, and then we add 1.
Okay.
And then now the loop starts running again.
Yeah. So
Going like
how
this.
does it? But now 2 is not considered.
2 is not considered, but we already compared it in the last one, right? We already compared 2 and 7, so we don't need to really look in here.
Oh, I see. Because you already went 2 and 7, 2 and 11.
Yeah,
2
exactly.
and
We already
15.
compared 2 to everyone, so we don't need to consider it anymore.
Okay, yeah,
We can just
yeah.
move the next one. So now this loops, right?
Okay, I
And
see.
now it exits.
Because
Now
like it wouldn't
that-
make sense for like once you're at 15, you're comparing it with 2 again when you already compared 2
Yeah,
and
yeah,
15.
exactly.
Ah,
Yeah, yeah.
I see, I see.
like already in the first iteration,
Okay,
you
yeah,
compared
yeah,
2
yeah.
to every single other element.
I think I'm mixing questions up.
Yeah. Does that make sense now?
Yeah.
You see how you do the double for loop to like
Yeah,
compare every
yeah,
single
yeah.
element? So that's one way. We already showed your way, which is the n log n algorithm. That's an O of n squared algorithm.
Yeah.
But there's a more subtle algorithm called O of n. And the way you can do this is just due to like the fact that like target is equal to x plus y. Like pretend we already know x, right? Like pretend we seen x.
Yeah.
What do we need to see in order to get like it, in order to like get target if we minus x here? Then all we need to know is like if we ever see a y, then there and like there was an x before, we can hit the target.
What?
It's easier with an example. Easier with example.
Oh man, this is getting complicated.
And I'm gonna
Like all I could do, I could just figure the sort thing out.
no, you'll get this when you see it. So right, what's the target?
Wait. Turn that down for a sec.
Target equals 9. So if the target is equals 9, so what are we doing? Basically, the fixed or the most optimal solution for this is using a hash map.
Yeah, isn't that what I was saying though?
Where you weren't using a hash
Okay, it
map,
wasn't. Yeah,
but
it
you use it
wasn't.
in a different way. Okay,
like I kind of did that though with the tuple thing.
okay. Pretend I see the element 2, right? I just need to know, did I see a 7? Like, cause if I'm at a 2, right?
Okay.
How do I get to 9? What other element do I need to get to 9?
Like 9 minus something, like 9 minus 2, anywhere between 9 minus 2.
And exactly 9 minus 2. I need exactly a 7 in order with me
Okay.
to get to 9.
So
But I haven't
okay.
seen one yet, so I'll be like, whatever. Oh shoot.
You haven't seen one yet.
Yeah, dude. Right. So now I'm at 2. Let's just say. Let me delete this.
Holy, this Excalidraw is crazy good.
So now we saw 2, right? Now let's do this. Let's say we saw 2. Since we don't have a result yet, we'll just say we saw 2 at index 0, right? Now we move
2 at index 0.
Yeah, we're just tracking that we saw the element 2 at index 0.
Okay.
Now we see 11, right? We see 11, and how do we get to 9? We would have need to see a negative 2 before in order for us to get to 9, but we didn't.
Yeah, it's not possible.
But because we didn't see one there, so we'll
Yeah.
just be like, okay, cool. Let's just track that we saw 11 at index 1. Okay, now we get to 7. 7. How would I get to 9? I would have had to see a 2 somewhere, right?
Yeah.
How would I have, like, then I look in my hash map. I'm like, I'll ask the question, did I see a 2?
Yeah.
It's like, oh, you did see a 2 at index 0.
I see.
Then I'll be like, okay, I'll return 0 and the current index I'm on. So you can literally just do this in one pass.
Holy moly. Yeah, I see what you.
Does that make sense?
You mean. Yeah.
Yeah.
Yeah. Show me the code for that.
I'll show you the code.
No, don't do the ChatGPT thing. Write it line by line so
Okay.
I could actually understand like what's going on.
Okay. Cause you already wrote it in GPT.
Yeah, I know, but like I actually didn't.
Okay,
read
the
it.
target here. So
Actually
we
didn't
need
read
to
that.
build a hash map, and the best way to build a hash map is a dictionary, and we want to store in the hash map. We want to
Man,
store
what
in the
should we name this video? After.
to some like deep dive or something like that. That one's gonna bang. Oh shoot.
Oh, shoot.
See, we're gonna store different keys. We're gonna store the element we saw and its index. That's what we're gonna store in our hash map.
Okay.
And we're pretty much gonna loop from like the end, like from the start to the end. So we're gonna just like for I and range that.
Could
right?
you use enumerate?
Yeah, you can use enumerate. You want to learn that one?
Yeah. Let's run that a couple times.
In enumerate
For
no.
index element.
Yeah. It essentially returns a
Enumerate,
tuple, but this is a way to extract the 0th element and extract the first element. So if we do just this,
How? What? How is this function working?
under the hood,
Yeah, like for index. I don't get the syntax. Like, isn't it usually like what you want for a certain thing in this? Like how you
Yeah,
are
exactly.
you just doing the for first?
well, usually it's like this for element in nums. So that just gets us the elements, right?
Yeah.
But if we add enumerate, then we get the index next to the element in like a
I
tuple.
see, and then it just prints it out. Okay, you're
Yeah.
not actually making you're not making
Yeah,
you're
enumerate.
not actually making anything. You're
Enumerate
just
basically
printing.
transforms this to have the index as the 0th index, like the
Yeah,
index
yeah,
with
yeah,
it.
yeah.
Like basically what we did.
Yeah.
So when you see here, we're enumerating. If I do element here,
Why don't you put this into a variable?
like watch, we print element here, right? It's more shorthand. Look, we're printing the element, and you can see it's like that.
I see.
The way I was doing it is I was just like,
Enumerate always outputs a tuple.
yeah, it always outputs a tuple where the index is the first element and is the 0th element, and then so we can also do this, right? And now I'm destructuring it, and now this is how you extract the 0th and 1th element out of it instead of like accessing the index. This is shorthand. So see, now it's printing. And then I could even just like go in here and then shorten that even harder. Those are like that's like how you build up to it.
Wow.
Okay, now we want to build our hash map, and we basically in the hash
Okay,
map we
yeah.
want to know who we seen.
Like, why don't you just put this into like list comprehension to automatically make a hash map out of it?
Then we have to do 2 passes. I just want to do this in 1 pass.
Oh, I see.
We could.
Cause yeah, like basically what you're doing is like as you go in, then you're gonna append. You're gonna append
Yeah.
to that.
So
you're,
we could-
you're doing like a blank.
So we're at index and element, and we'll say we'll be like we're looking for target minus my element, or let's just call this num. So what's target? So why are we looking for target minus num? Because if we've seen that number, we know that if we add that number to this current number, we'll get the target,
Sure.
right?
Yeah.
That's just like basic
this is algebra.
math. Yeah, algebra, right? If looking for is in scene, then we'll return.
Okay, so like let's say you're trying to master this stuff. Are you just remembering?
This is one that you kind no. You do it and you like these are like table stakes ones that you kind of like some people just learn it straight up. But
Like, how do you? Like, you're just supposed to know this. It's just
no,
like a
it's
basic.
not.
thing.
You'll figure it out if you look at it hard enough. But you won't figure it out if you just start coding.
Ah, I see.
Like like me, like I figured out by just staring at this and saying, oh, they want better than O of n squared. And you have to understand the different runtime complexities and what's slowing it down. So you're looking, oh, the sort is slowing it down. Can I do it in 1 pass? Then you start thinking of ways you can do it in 1
Yeah,
pass.
so you kind of go line by line, like what's this lines and complexity, like
Yeah,
space. And
exactly.
time
That's why I
complexity.
started off with O of n squared. Like you might not know that, but you see O of n squared, you're okay, that's kind of bad. How can I speed it up? And then you look for bottlenecks, things
Yeah.
that are slowing it
Yeah,
down.
so eventually, like you kind of try to like flatten.
Yeah, you're like gradient descenting. You're
see.
usually come up with the brute
I
force,
see.
and then you're looking at your algorithm like what's slow, and that's why big O complexity is so important. You need to know what's slowing down your algorithm, and then
I
from
see.
there, and then there we optimized it.
Okay.
See, like that's why engineers really need to know big O. Like if anyone in the channel is like wants to be an engineer, study your big O's. That's like table stakes.
Yeah, but even for like quantitative finance, you kind
Everybody
of need to know that.
yeah, you'll need to like it'll help you think about how you're doing joins and stuff better too, like what's slowing it down.
Oh, okay, yeah, like in SQL.
So if looking for is in scene, that means we've seen like that one. We return the index of it, right? Because we were storing the index. Else, we just add scene and we put we say we seen this num at a specific index. Make sense?
Yeah, let me.
Beats 100%, baby.
Holy, okay, let run through this code line by line. So you're initiating a list.
We're initiating a list. We're enumerating through the list.
Yeah.
Enumerating means we're just augmenting each element with its index
Yeah.
because we want to return index. That's kind of useful. We're creating a scene array where the scene array is mapping elements to an index.
Yeah.
And we're basically seeing we're just tracking where we seen elements.
Yeah.
And the reason we're tracking where we seen elements is because we want to know where we seen it in order to return the index for the
Yeah.
result.
But
If we
see-
didn't care, if we just want to return true, the moment we wouldn't even need to
Yeah.
store the index.
Yeah.
So if we basically look like we're looking for target minus num because we're looking for a number that like if you arrange this num plus target num or target looking for plus num should equal a target. So we're looking for that specific value.
Right.
So pretend I see a 7. If I'm 7
Yeah.
and the target is 9, then I'm looking for a 2 because that 2 will complement
Yeah.
me in getting to my target. So
Every-
then
so
I ask the
enumerate's
question.
just like a part of Python.
Yeah, it's a Python function. Like this is not even part of the solution. It's more just a helper function to like get us the index because we're trying to return the indexes here, right?
Yeah.
Okay, lastly,
I see.
This scene array, we're asking questions to this hash map, and asking questions takes like O1 space complexity based on how hash maps are implemented.
Dang,
And I'll explain that.
Everything slaps though.
Slaps.
You could do it on a lot of different things.
That's what I'm saying. Just learn the array operations and go ham.
I see. Cause yeah, like even this one, right? I'm kind of doing. Oh no, it's gone. But yeah, we'll go on in.
So basically, I'm looking for a specific element
Yeah.
in scene. If it's in scene, then I just return the index where I saw it and my current index.
Yeah.
Otherwise, I just be like, okay, I'm just gonna track that number. I saw 2 on this index. That's what I kind of did here.
Yeah.
And then when we eventually run into 7, 2 is gonna be in there. So when I ask the question, did I see 2?
Yeah.
It's gonna be like, yeah, you did. Here's the index. And I'll be like, okay, I'll return that and my current index. Over in time. Another 1 hour long movie.
Oh my god.
So, what did you learn? Like, did we dig?
I think like the enumerate thing
Love that one.
is what comes to mind first, and then like really being mindful of this time and space complexity.
Yeah.
I would say.
I would say, like, since you're a beginner, don't worry about it too hard, but no, like, you're not going to find the optimal algorithm right away because first off, you didn't know to, like, you were thinking about a hash map, but like, you'll just learn to apply it in different places. That's what I'm saying. You need to learn the different tools for the toolbox kind of thing too.
Yeah, yeah.
And this is just like one tool, like using a hash map to store like elements to indexes, and that's just like one algorithm.
Yeah.
You'll use this in other algorithms
Yeah.
too, but yeah, that's pretty much it, everybody. Those were the operations. We literally went through all.
Dang, I forgot how I did mine.
Like, we literally
now.
went through the brute force, which is that n squared algorithm.
Oh my goodness, there's a way to do it. I didn't know that there's videos.
Dude, there's videos and they're really good, and they show you the solutions.
What the heck?
You should pay for premium, bro.
Is this premium? How are you seeing this right now?
Well, they only for common ones they show you.
Okay.
There's
Maybe
2 pass hash.
I gotta spend my money elsewhere right now.
Yeah, there's
I
1
gotta
pass
spend it on
hash.
the
I can
1K
just
to
tell.
10K.
Yeah, I can just tell you the examples.
I see.
You did like a yours isn't really in there. I don't know why.
Oh, mine isn't in there?
I don't know why.
Is that bad? My gosh.
But yeah.
Okay.
Yeah, I want to do your.
Let's see
outro.
my submission again.
Where?
How did I do it? Is it weird that like when I do my thing, I don't really remember how like the logic behind it.
No,
I'm kind of
but-
running it line by line, and
That's
then
good,
like when
yeah.
I read my own code, I'm like, what the heck did I do exactly?
Yeah. Another skill is reading your own code after. So sometimes read it and just try to understand why it works. Because like when you become an engineer, you'll be reading other people's code and trying to figure out what they did. They'll solve this question, you'll be looking at like, why'd they do it like that? And you're trying to understand why they did it like that.
Yeah.
That's like even a harder
Yeah.
skill because everyone kind of writes code in their own way. But you'll understand it. Like when you did it, I just understood it because I've seen this question.
Yeah.
Yeah.
Because yeah, really what I'm doing is I'm just doing the pointer thing.
I like that approach. Like,
'Cause, like-
you thought of that yourself too?
Well, remember we were doing that one question? Holy, why are they loud on there? But remember that one question where we were trying to do like the what's it called? That one, like we were trying to not use, like we were trying to sort like arrays.
Yeah. Was that
The
yesterday
array-
that I was
That
doing
was like
question?
2 or 3 days ago. We were like trying to sort the arrays without using more memory.
Yeah.
And then that's like the only,
Yeah.
I mean, like I kind of cling to that, that pointer
Cool.
thing.
Sounds good. All right. Thanks, everyone. That's
Yeah.
Twosome.
Holy.
That's good stuff. See y'all in the
Yeah,
next
please like
video.
and subscribe. Bye.